I'd like to introduce you to Jenny, known also simply as the Tombot Puppy Robot, an emotional support robot dog designed especially for people who cannot care for live pets, including seniors with dementia or mild cognitive impairment and others with mental health challenges. The story of Jenny begins with its creators, the company Tombot, Inc. Founded in 2017 by Tom Stevens, CEO, together with co-founders including Hank Shores, CTO, and Jesse Shores, the mission was personal. Tom Stevens was motivated by his own mother's struggle. After she developed Alzheimer's dementia, she had to surrender her dog for safety reasons, which exacerbated her loneliness and depression. Stevens saw a larger underserved population, over 300 million seniors worldwide with dementia or mild cognitive impairment who, for various reasons, cannot keep a live animal companion. Tombot was born of that motive, combining robotics, therapeutic design, and emotional support. Development of Jenny took place over several years. Tombot started prototyping, gathering feedback, doing studies with clinical experts, patients, and families to refine what behaviors, appearances, and interactions would be most helpful. The company collaborated with Jim Henson's Creature Shop, renowned for animatronics and creature effects, for the artistic appearance and design of Jenny, so it could look, feel, move, and behave in ways more realistic and emotionally resonant than many robotic pets. The initial versions have gone through alpha and beta engineering stages. As of early 2025, Jenny was being shown publicly, for example at CES 2025, and pre-orders waitlist reservations were being taken, with shipping expected to begin in 2025 or early 2026, depending on final production and certification steps. In its main features and specifications, Jenny aims to replicate many aspects of a young Labrador Retriever puppy of about 8 to 10 weeks old. Jenny responds to touch. Different kinds of touch, gentle petting, vigorous petting, being held. She has voice command ability, responding to her name, obeying certain commands such as speak, and makes real puppy sounds, barking, whining, howling, cooing, snoring, using recordings from actual pups. Her head, neck, ears, muzzle move, eyes open and close, she can wag her tail. She has sensors to distinguish between different types of interaction, and a smartphone app for customization, naming, configuring certain behaviors, software updates, monitoring usage. She is battery-powered, rechargeable. As for body structure and materials, while exact full details are not always public, what is known is that Jenny has synthetic fur to mimic the feel of a puppy, and underlying actuators, motors to move facial features, ears, eyebrows, nose, muzzle, head, neck, tail wagging. There are many sensors under the synthetic fur, at least dozens, in some descriptions, 50 sensors under the synthetic fur, that detect touch, location, pressure, movement. The materials are chosen for realism, soft fur, skin-like materials, animatronic design for expression. The design is such that Jenny is non-mobile in terms of walking. She lies on a pillow or in a lap. She cannot walk or run, but can move parts to give expressive behavior. This choice is deliberate, partly to avoid safety risks for elderly users, falls, tripping, and other complications. On how Jenny works. The robot's working mechanism combines sensors, actuators, embedded processing, AI, behavioral software, and user interface. Multiple touch sensors detect how and where the user is touching Jenny, and distinguish speed, strength of touch. Microphone's hearing capabilities allow it to detect voice commands. There is voice recognition enough to respond to its name and commands like, speak. Actuators, motors, head, neck, ears, muzzle, tail generate movement, blinking, opening, closing eyes, mouth movement. The AI, behavioral software, interprets sensor input and maps it to behaviors, for example, if petted gently, for a longer duration, respond with contented behavior, if voice command, trigger sound, if no interaction, go to, sleep, snore. Also, there is a smartphone app that allows configuration, naming, monitoring engagement, receiving updates. The power system is rechargeable. Battery life is intended to last through daily usage, with charging overnight. There is no walking mechanism, no legs moving, which simplifies design and safety. As for more advanced AI, there are studies underway, clinical testing with seniors with dementia, a goal to register Jenny as a medical device in the US, via the FDA, especially for use in care facilities. In terms of price and estimated cost, Jenny is expected to retail for about US $1,500 per unit. Pre-orders waitlist customers number in the tens of thousands, more than 15,000 in some reports, and over 8,000 pre-order waitlist customers at certain earlier stages. There is also mention of institutional, rental or B2B customers, hospitals, assisted living, memory care facilities that may buy in bulk. The country of origin is the United States. Tombot is based in Santa Clarita, California. Thinking ahead to future benefits and applications for humanity, Jenny and similar robotic emotional support animals could provide companionship and reduce loneliness, especially among individuals who cannot keep or care for a live pet due to allergies, mobility issues, cognitive decline, institutional settings. For seniors with dementia or mild cognitive impairment, interactions with Jenny may help reduce agitation, anxiety, depression, hallucinations, improve mood, increase social interactions, and provide comfort. Also, because robotic pets don't require feeding, walking, vet care, or long-term care, they can be more accessible and lower risk for many caregivers and institutions. They may also be useful in therapeutic settings, in hospitals, memory care, assisted living, and possibly for children with autism, PTSD, anxiety disorders, or other conditions where emotional regulation and companionship are beneficial. There is also potential for remote monitoring. The robot could collect data on engagement, mood, how often it's interacted with, which could be useful for caregivers, clinicians, or researchers, always respecting privacy to tailor care and assess progress. As for hidden or less known facts, there are several interesting subtleties. For example, the decision not to make Jenny walk was intentional, to reduce safety hazards e.g. falls, tripping, especially in users who may have mobility issues. Jenny is meant to lie down, on the lap or on an armrest or a pillow. Another subtlety is that while the robot is designed to mimic real dog behaviors, it is not intended to deceive people into believing it is a real dog. Tombot is transparent about Jenny being a robot. Also, many prototypes were tested with seniors, 700 plus with dementia in the Los Angeles area, to get feedback on behavior, feel, reactions. Another lesser-known challenge is the delays in getting to production. Technical complexity, cost of goods, supply chain, regulatory certification, especially if aiming for FDA approvals, have pushed back timelines. Also, although the name, Jenny, is used, users can rename the robot via the app. Finally, possible future developments and impact include expanding Jenny's capabilities, more behaviors, more responsive AI, possibly improved autonomy in motion or interaction, though walking may always carry safety trade-offs, richer sensory feedback, e.g. more precise touch, thermal feedback, even smell, possibly integrating health monitoring sensors, heart rate, skin conductance to detect user emotional or physical states, more personalization and adaptive behavior, longer battery life, easier maintenance, more affordable versions or rental models for institutions. Also, as regulatory certification, such as with the FDA, is achieved, Jenny could be deployed more widely in clinical settings, becoming an accepted assistive therapy tool in mental health care, geriatric care, memory care. On a broader scale, the impact could be significant, reducing the need for psychotropic medications in dementia care, reducing caregiver burden, improving quality of life for many who are isolated. If scaled, robots like Jenny may become mainstream companions for mental well-being, not only for the elderly but also children, people with disabilities, people with chronic illness, those in remote or isolated settings. There is also the potential social and ethical impact, how people relate to robotic companions, how care systems integrate non-human companionship, ensuring safety, data privacy, and emotional considerations. In sum, Jenny is a promising step toward combining robotics, therapy, and companionship, and though there are challenges ahead, its development signals a future where emotional support robots could make lives richer and more bearable for many.